Okay, let's continue the topic on the modulus function. Example 4. Determine if the following are true or false for all real values of a and b. Let's look at the first one. The modulus of a plus b equals the modulus of a plus the modulus of b. Is this one true or false? This one is false. Okay, if I want to say this one is false, the only thing I need to do is give myself a counter example. For example, if a value is -1, b value is 2, you will see the left side is the absolute value of -1 plus 2. Using the bad math, you can get the absolute value of -1 plus 2 is the absolute value of 1, which is 1. And the right side is the absolute value of -1 plus the absolute value of 2. This one is 1. This one is 2. 1 plus 2 is 3. That means the left side is not equal to the right side when a is -1, b is 2. So this one is not true for all real values of a and b. Similarly, the second one, the absolute value of a minus b equals the absolute value of a minus the absolute value of b. This one is also false. Let's pick up two numbers. If a is 3, b is -2. With these two numbers, the left side is the absolute value of 3 minus brackets -2. And this value is 5. And the right side is the absolute value of 3 minus the absolute value of -2. And this one is 3, and this one is 2. 3 minus 2 is 1. So we can see that the left side is not equal to the right side. This one is not true for all real values. And this one, this is a very important property of the modulus signs. Or we can see the absolute value. The absolute value of a times b equals the absolute value of a times absolute value of b. You can pick up any numbers for a and b. The test will always be true. And this one is always true for all real values. This one is the multiplication property for the absolute value. And this one is the division property for the absolute value. More properties of absolute value. The absolute value of x is larger than or equal to 0 for any x value. The absolute value of x squared equals x squared for all x value. The absolute value of x over y equals the absolute value of x over the absolute value of y. The absolute value of -x is the same as the absolute value of x. This one is true for all x values. And this is multiplication property that we just talked about in example 4. The absolute value of x minus y equals the absolute value of y minus x. So in the absolute value, if you want to switch these two numbers around in the minus sign, the subtractions with the absolute value should be equal. Okay, this is a very important part that we need to learn. Solve modulus questions and inequalities. Let's look at example 5 first. How can we solve this modulus equation? The absolute value of x equals 3. We will know the absolute value of 3 is 3. The absolute value of -3 is also 3. In this case, I will know this x value can be positive or -3. So we can generalize this equation. We say this absolute value of x equals a, as long as is our non-negative value. This x value is positive or negative a. This is also the solution for this modulus equation. Right now we need to use this generalization to solve the other two absolute value equations. Let's look at this one. This one is not a simple x here anymore. It's 2x plus 3 inside the absolute value symbol. But it's the same as x. I will take this one as one family. 2x plus 3 equals plus or minus 7. So here, from this one, you can get 2x plus 3 can be positive 7. Or 2x plus 3 can be negative 7. 2x plus 3 is 7. Let's continue to solve x value. It's 2x equals 4. Divide both sides by 2. Then x equals 2. For this one, it's 2x equals negative 10. Divide both sides by 2. The x is negative 5. So the solutions of this modulus equation are x equals 2 or x equals negative 5. You can plug both of these two solutions into this modulus equation. Both of these two values can make this equation true. Let's look at this one. This one is a little bit different because this side is negative 1. But we know the absolute value of x is always larger than or equal to 0 for all real number values. No matter what the x is, once you put the absolute value on the x value, this absolute value will never be negative anymore. But this absolute value is negative, which suggests this equation has no solution. There's no way for us to find an x value such that this absolute value is equal to negative 1. Let's look at a little bit more complicated absolute value equations. A, B, C. But C, for this case, it's not required in DP course. We can skip this one. Let's look at the first one. This is a rational equation with the absolute value. But anyways, I will take this one inside as the entire family. So this one is 3x plus 2 over 1 minus x equals positive or negative 4. So I will get two rational equations. One is 3x plus 2 over 1 minus x equals positive 4. Or the other one is 3x plus 2 over 1 minus x equals negative 4. Now let's solve these two rational equations. When we solve two rational equations, we multiply both sides by the denominator. So this blue equation will become 3x plus 2 equals 4 times 1 minus x. Then expand the brackets here. 3x plus 2 equals 4 minus 4x. Move negative 4x to this side. Move 2 to the right side. We will have 3x plus 4x equals 4 minus 2. So it's 7x equals 2. Then divide both sides by 7. X equals 2 sevenths. Let's look at the red one. Exactly the same. We multiply both sides by 1 minus x, so we can get 3x plus 2 equals negative 4 times 1 minus x. Open the brackets here. 3x plus 2 equals negative 4 plus 4x. Isolate x term from the constants. So it's 3x minus 4x equals negative 4 minus 2. This one is negative x equals negative 6. Divide both sides by negative 1. X equals 6. So the final solutions of this equation can be 2/7 or x equals 6. Right now, let's look at how can we solve this one. If you have two absolute values in one equation, but without any other numbers involved, like this one we still have a constant at the end. So compare with this one is way easier. Let's look at how can I solve this one. One absolute value of something equals the absolute value of something too. So what I can do is I remove the absolute value. X plus 1 equals positive or negative brackets 2 x minus 3. You still have two equations. The first one is x plus 1 equals 2x minus 3. Or the other one is x plus 1 equals negative brackets 2x minus 3. Let's solve this linear equation. It's x minus 2x equals negative 3 minus 1. So it's negative x equals negative 4. Divide both sides by negative 1, x equals 4. X plus 1 equals negative 2x plus 3. Then isolate x term from the constants. So it's x plus 2x equals 3 minus 1. This is 3x. This is 2. Divide both sides by 3. So x equals 2/3. So in this equation, we also can find two solutions. One is x equals 4 or x equals 2/3.